In this video, we're going to discuss how to find the value of an inverse cosine function. As a quick reminder, the inverse cosine function is defined as y equals inverse cosine of x if and only if x equals cosine of y, where x is between -1 to 1 inclusive of the endpoints and y is between 0 and pi inclusive. In this example, we'll be finding the exact value of an inverse cosine function. And this problem states, find the value of inverse cosine of 1. If we let theta equal inverse cosine of 1, then cosine of theta equals 1 for 0 less than or equal to theta less than or equal to pi. The value of theta for which cosine is 1 in the given interval of theta is theta equals 0. Therefore, inverse cosine of 1 is equal to 0. And here we have graphed the cosine function in the viewing window for x between negative pi to 5 pi over 2 and y between -1 to 1. Recall that there are infinitely many values of theta for which cosine of theta equals 1, such as theta equals 0, plus or minus 2 pi, plus or minus 4 pi, and so on. However, based on the restricted cosine function that is 1 to 1, over the domain of 0 to pi inclusive, there's only one value of theta for which cosine equals 1, and that is theta equals 0. So there's only one output for the inverse cosine of 1, and thus inverse cosine of 1 equals 0. In this example, we'll be finding the exact value of an inverse cosine function. Now this problem states, find the value of inverse cosine of the quantity -1/2. Now if we let theta equal inverse cosine of the quantity -1/2, then cosine of theta equals -1/2 for theta between 0 and pi, inclusive of the endpoints. Now the value of theta for which cosine is -1/2 in the given interval of theta is when theta is equal to 2 pi divided by 3. Therefore, we write inverse cosine of the quantity -1/2 equals 2 pi divided by 3.